are oxidized by potassium manganate 7 to the corresponding acids. As the reaction proceeds, the purple color of manganate 7 ions fades away and a dark brown precipitate of manganese 4 oxide is formed. Aldehydes are also oxidized by potassium dichromate 6 in acidic solution. The orange color of the dichromate 6 ions changes to green, which is characteristic of chromium 3 ions.
First I make up some fresh feeling solution. Here I've got feelings 1 solution, feelings 2 solution, a beaker of hot water, and I'm going to use the aldehyde ethanol for this test. I take a clean test tube and add a couple of cubic centimeters of feelings 1, which is an aqueous solution of copper 2 sulfate. And to this I'll add in a dropwise fashion the colourless clear solution feelings 2, which is a solution of potassium sodium tartrate and sodium hydroxide. Now watch how a precipitate forms here. This is a precipitate of copper 2 hydroxide. But as I continue to add a little bit more, the precipitate redissolves and I get a deep blue or royal blue solution, reminiscent in colour to copper tetraamine that you may be familiar with. So we've got copper ions complexed in solution there. I'm going to add about 2 cubic centimeters of the aldehyde ethanol. I'll flush it in using a dropper, give it a good shake, and place it in a hot water bath and watch what happens. The aldehyde will undergo oxidation, and as it's oxidized, it will behave as a reducing agent and it will reduce the feeling solution. Specifically, it reduces the copper 2 ions in feeling solution to copper 1, and we get insoluble copper 1 oxide formed, which is a brick red colour. If you look at the structure of the aldehyde, you'll see that the carbon of the carbonyl group has a hydrogen attached to it. That's what allows it to undergo oxidation, whereas the ketone doesn't have a hydrogen in the same location and it does not undergo oxidation. We say the aldehyde undergoes oxidation. We also say that it behaves as a reducing agent. Aldehydes can reduce feeling solution, ketones can't. The other two tests that you will see here use Tollen's reagent and acidified potassium dichromate.
Using Tollen's reagent to test for aldehydes. The silver mirror test. This video demonstrates how to use tolerance reagent to test for aldehydes. This video first demonstrates the preparation of tolerance reagent. Two tests will then be carried out. One shows a positive result, and the other shows a negative result. Preparation of tolerance reagent. Add 2 ml of 0.3 molar silver nitrate solution into a clean test tube. And then add 1 to 2 drops of 0.3 molar sodium hydroxide solution. Brownish precipitate of silver oxide will be formed. Add a 3 molar aqueous ammonia solution drop by drop with a dropper, until all the silver oxide precipitate is just dissolved. Do not add excess amount of the ammonia solution. The solution obtained is aqueous diamine silver solution, which is also known as tolerance reagent. Add a small amount of sample to the tolerance reagent. Shake the mixture gently, and then stand it on the bench for 10 minutes. Observe if there is a silver coating formed on the inner surface of the test tube. If there is no observable change, warm the mixture in a warm water bath for 5 minutes. If the sample is an aldehyde, a positive test result will be obtained. If the sample is not an aldehyde, the test will give a negative result. It is important that tolerance reagent should be freshly prepared. Prior to disposal, the reagent must be acidified immediately after use. The addition of acid prevents the formation of explosive silver nitride.
Schiff's reagent is used for the detection of aldehydes. In their presence, the initially colorless Schiff's reagent turns purple.